The building block of matter. Kind of important since we're all made of matter. So, to get a better understanding of the atom, we're going to look at the modern view of an atom, which consists of a positive center that's tightly packed, that's referred to as the nucleus. Now, this is where all the protons and neutrons reside. The protons are positive, the neutrons are neutral. And that is surrounded by a region where the electrons reside. And this can be referred to as the electron cloud. Now, the electrons are negatively charged and kind of dictate what properties an element will have. This is essentially where the real chemistry takes place, with the exception of nuclear chemistry. So, once again, the protons and neutrons are in the nucleus, protons being positive, neutrons being neutral, giving an overall positive charge, and the electrons are in the region around that, which give a negative charge. Now, there might be other ways that you've seen this represented, such as the Bohr model, which has a positive nucleus that is orbited by electrons, the negatively charged electrons. And you may have seen it depicted as orbitals. Now, for orbitals, this is a region in space where electrons are likely to reside. So if we actually think about, say, this electron here, it's actually a combination of all these orbitals combined. Now, if you can imagine pushing all those together, you end up with something that looks fairly spherical, maybe with some light bumps in it. So I like to equate it to looking similar to a fancy napkin or a doily. And if we were to talk about this a little bit differently, we can say that this napkin is circular in nature. Now, it's not 100% true, but it is overall a circular shape, much like the orbitals are with the drawn modern view of the atom. Overall, this napkin is circular, and overall, the electrons reside in a kind of spherical area around the nucleus. So, since most of the chemistry happens with how these electrons are behaving, a lot of that is dictated by the nucleus. So let's talk a little bit about the nucleus. So a couple things about the nucleus is that the nucleus contains all the protons and neutrons found in the atom. Now, these protons and neutrons actually have a very similar mass in what make up most of the mass of the atom. The number of protons is referred to as the atomic number, which is often depicted as the letter Z. And this will determine what the element is. So all the elements are essentially defined by how many protons they have. The number of neutrons may vary among the different forms of a particular element, and this is what gives what we call isotopes. So, exact same number of protons, but if they have different amounts of neutrons, they are called different isotopes. And lastly, the number of protons plus the number of neutrons is equal to the mass number, oftentimes depicted as a capital A. Now, it may also be written as mass or other things of that nature. So let's take a look at a couple of examples here. So we have chlorine-37, where the Cl here is the chemical symbol, and this is essentially the abbreviation you'll see whenever you're looking at a periodic table, so you know what the element is. In this case, chlorine is Cl. And then we have the 17 written down here, and this is the atomic number, or Z. Alright, so this is the number of protons found in chlorine. And then this 37 is the mass number. all right, also written as A. So if we were to look at this chlorine 37, we'd say, all right, it has 17 protons, and the number of protons plus neutrons is equal to 37. So if we want to find the number of neutrons, we could simply do 37 minus 17 will give us 20 neutrons. And so that's how we can figure out how many neutrons are in this isotope. Now if we compare that with chlorine 37, give me just a second here. We compare that with chlorine 35, then we can see that it still has 17 protons, and this time it has 35 protons plus neutrons. So that would give us a total of 18 neutrons. So one of the things to kind of keep in mind here is that for chlorine, our atomic number is always 17. We always have 17 protons. By definition, that's what makes chlorine. So all of our elements are determined by the number of protons that they contain. So oftentimes, chemists will try to make life a little bit easier on them, or they will try to, what I've been told is, be more efficient. We actually drop off that 17 subscript, and we'll just simply write chlorine 37, or we'd write chlorine 35. So normally whenever you're talking about an isotope, you'll normally mention the element and then follow it up with the mass number. This is our quick, slow summary of what atoms are and their general structure. So look forward to seeing you on the next video.